Have you ever wondered if the famous Italian polymath and painter Leonardo da Vinci had any knowledge about gravity? It turns out that engineers from the California Institute of Technology have discovered that Da Vinci's understanding of gravity, although not wholly accurate, was centuries ahead of his time. Welcome to Curious Media. In this video, we will discuss how recent research has found that Da Vinci's sketches from centuries ago show that he may have understood key aspects of gravity long before Galileo, Newton, and Einstein. This is an exciting discovery that will change the way we perceive Da Vinci's contributions to science and the world. Lost Sketches by Leonardo da Vinci. Recent research from the California Institute of Technology has revealed that long-forgotten diagrams in Leonardo da Vinci's notebooks show experiments from the early 1500s of particles fallen from a pitcher, demonstrating that gravity is a form of acceleration. Da Vinci, who lived from 1452 to 1519, was well ahead of the curve in exploring these concepts. It wasn't until 1604 that Galileo Galilei would theorize that the distance covered by a falling object was proportional to the square of time elapsed, and not until the late 17th century that Sir Isaac Newton would expand on that to develop a law of universal gravitation, describing how objects are attracted to one another. One of Da Vinci's sketches details an experiment involving pouring water from a pitcher to help understand the effects of gravity. Da Vinci's experiments were first spotted by Maury Garib, the Hans W. Liepmann Professor of Aeronautics and Medical Engineering, in the Codex Arundel, a collection of papers written by Da Vinci that cover science, art, and personal topics. Decoding Da Vinci's notes. Garib and his team of researchers had to translate Da Vinci's notes into Italian, which were written in his renowned left-handed mirror writing that reads from right to left, to analyze the sketches. The researchers then carried out Da Vinci's experiments using computer simulations. According to Da Vinci's notes, the velocity of the falling material accelerates downwards, and as the particles fall, they are no longer influenced by the pitcher, but are instead accelerated by gravity pulling them downward. However, at the time, he was unable to translate his observations into an equation. What we saw is that Leonardo wrestled with this, but he modeled it as the falling object's distance was proportional to 2 to the t power, with t representing time, instead of proportional to squared. Chris Rowe, co-author of the study and assistant professor at Cornell University, said in a statement, "It's wrong," but we later found out that he used this sort of wrong equation in the correct way. When modeling the water vase experiments, the team yielded the same error Da Vinci did centuries ago. Da Vinci's limitations. Da Vinci's primary hurdle was being limited by the tools at his disposal. For example, he lacked a means of precisely measuring time as objects fell. This was a significant limitation in his experiments and his understanding of gravity, as his observations were made using his naked eye. Despite these limitations, Da Vinci's sketches show that he was still able to understand key aspects of gravity, including that it is a form of acceleration. The significance of Da Vinci's understanding of gravity. The significance of Da Vinci's understanding of gravity cannot be overstated. His experiments and observations show that he was well ahead of his time and had a deep understanding of the natural world. Da Vinci's understanding of gravity would have far-reaching implications for future generations, laying the foundation for scientific discoveries that would eventually revolutionize the world. Da Vinci's understanding of gravity also highlights the importance of experimentation and observation in scientific inquiry. He was not content to simply theorize about the world around him, but instead sought to understand it through rigorous experimentation and observation. This approach would serve as a model for future scientists and helped pave the way for the scientific revolution. Moreover, Da Vinci's legacy as a polymath is a testament to the power of interdisciplinary thinking. His understanding of art, science, and engineering enabled him to see the world in a unique way and make groundbreaking discoveries that would have been impossible for someone with a more narrow focus. By studying Da Vinci's work, we can learn about the importance of interdisciplinary thinking and its potential to drive innovation and progress. The legacy of Da Vinci's work. The legacy of Da Vinci's work is profound and enduring. His contributions to the fields of art, science, and engineering have had a lasting impact on the world and continue to inspire new generations of thinkers and innovators. Da Vinci's understanding of gravity, in particular, has had a significant impact on the way we understand the natural world. His experiments and observations laid the foundation for the work of future scientists such as Galileo, Newton, and Einstein, and helped pave the way for the scientific revolution. Today, Da Vinci's work continues to be studied and celebrated around the world. His notebooks, filled with sketches and observations, remain a treasure trove of knowledge and inspiration. By studying his work, we can gain a deeper understanding of the natural world and the power of human creativity and ingenuity. The lost sketches by Leonardo da Vinci that show his understanding of gravity are a remarkable testament to his genius and his unique approach to scientific inquiry. By exploring his work, we can gain a deeper understanding of the natural world and the potential of human creativity and ingenuity. We invite you to continue exploring the world of science and discovery with us on our channel Curious Media. Thanks for watching.